All right, let's take a look at this last example of simplifying radicals. We've got a cubed root of a power, a binomial raised to an exponent. A binomial raised to an exponent, this is still a power, okay? Whether it was just x or x minus 1, we've got a base of x minus 1 raised to the fifth. We've done a few of these videos already. I'm going to try again to avoid the rational exponent, even though it would work in this case. Anytime you have a power that's raised to an exponent that is greater than the root, in this case 5 is bigger than 3, I'm going to be able to write this as including a perfect cube. So, if I may, we're going to do what I call decomposing the power. I take this base of x minus 1 and I try to find that perfect cube that's in there. Think about your exponent rules. How might this 5 have come to be? Perhaps I took 5 of these and I multiplied them together. Maybe that's how I got x minus 1 to the fifth. Or maybe it was x to the fourth times x to the first. Because when I multiply powers that have the same base, I add their exponents. Well, let's do the opposite. Let's come up with something that benefits us in this problem. Oh, getting a little sloppy here. I've got a third root. So why not create a third power, a cubed, from this? And if this is cubed, what's the other term? Right? Something squared, because 3 plus 2 is 5. So we're essentially finding two numbers that add to be 5 when it's underneath this radical. Go back up and look at some of these. Okay? 3 plus 3 plus 1 is 7. I'm trying to find a sum that creates 7. I break it down into thirds because it was a third root. Here I didn't have to do that because this was a square root and this was in terms of a power of 4 and half of 4 is 2. I didn't have to do it here. But in this case, I'm looking for that perfect cube because I'm taking a cubed root. And this separates, watch the presto changeo here, this separates into two separate cube roots. I can separate a product into two separate roots. The cubed root of something cubed, it's going to cancel. So I have an x minus 1 that I was able to simplify out. Now there's still this degree underneath here because 2 is less than 3. I'm not going to be able to pull any more out of there. I was able to pull this out. This, not much I can do after that. That's as simple as one of these is going to get.